Okay, guys, it's 6 o'clock, so let's go ahead and begin. As always, I'd like to start off with looking at questions that you might have on either problem sets or something that you're working on. And then we're going to review once again forecasting performance. And then we're going to step into looking at different valuation model structures. So what kind of questions might you have from material you're working on?
So I had a question on the ICP project. On the very last one, it was trying to calculate the IRR,
Yeah,
but it was
won't do
giving
it,
me
will it?
no,
Yep. Yeah, in fact, I was hoping somebody would ask about that.
no. Well, mine actually calculated it, and it was I think I messed it up somehow. Or
Yeah,
maybe I wasn't putting the right values.
if it gave you an internal rate of return, it's an error. Something's wrong there, because you'll see in just a moment as I bring this up why you can't have an IRR on this particular one. So I'm going to bring it up, but not as the problem or solution set. I'm going to bring up the Excel file. Okay, this is what I was looking for. Okay, when I was at first looking for something else, I put together these templates, and then when I'm working with students like yourselves, we'll sometimes show what if examples, and so I changed the values in this and saved it inadvertently. So not only do we see that we don't come up with an internal rate of return doing this, we've got some other problems facing us as well. But first, let's tackle this one. Why do we not see an internal rate of return? Why is it giving us an error? What is the present value of the sum of all of the future benefits or cash flows for this company? You're looking right at it.
Negative. Is that the 119?
It's actually negative $300 million. So in order for me to be willing to buy this from you, Scott, you would have to pay me $300 million. Well, that doesn't even make sense, right? It's not going to happen. So if I pay 90 for it, which is going to have to show up as a negative, and then I have a negative cash flow, there is no return to get a rate on. So it's showing an error here because there's no return on which the investor can even calculate a rate. They paid 90 and then they went ahead and lost 300.
Okay.
Okay, does that make sense?
Yeah, that makes sense.
In fact, there's got to be a positive outcome in the benefits to be able to get a return. Otherwise, it would just be a loss. And the IRR calculation, as you might remember, is an iterative process. It's not a real singular algebraic calculation. And with that iterative process, it will not recognize a negative.
Can I ask a question then?
Please, Casey.
So with an internal rate of return, we're not saying you can't have a negative internal rate of return. That's just if your return is so slow and so bad, and the amount of years you're measuring is like you won't have a return in this amount of time. But if you have a situation in which there genuinely is no return ever, then you will get this error.
Yeah, right.
Okay. I just want to make sure, because it seems to stand to reason that if we were to cut this down to a 5-year period and change some of the figures where there might be a profit in 50 years, then you would just have a negative internal rate of return in that first 5 years.
In that first 5 years.
Right.
Yeah. So you're truncating time, right?
Yeah.
So we just haven't, and in that case, maybe we just haven't gotten our return yet. But because this continuation term takes into account all of perpetuity, everything else that could possibly be, we're done, brother. It's over. Right. It's over. Now, here's an interesting thing. We've got that negative value, not because of its explicit period cash flows. We got $120 million in present value of those explicit period cash flows, in part because we're stringing them out for 20 years. That's a long old time to do this, but in part because they are apparently healthy, robust, and they're nicely positive, right? So I asked you this question last night, I think on the phone, Scott. I'll ask it to the rest of us for a moment. So as investors, and Casey, I'll pick on you for a minute. Tell me what you don't like about this picture I'm going to paint for you. Here's a company, been around for, 8, 10 years, something like that. It's expressly positive in its cash flows. It's got a good growth rate of its cash flows. And it's got a lesser discount rate, a lesser cost of capital than it has return on capital. As an investor, what do you not like about that scenario?
Well, its long-term growth is disconcerting, right? Like it can't contain a long-term growth of 20% for that long.
Okay,
Also,
so I'll change it a little bit. What if we have a killer cost of funds, 3%, and we have a fairly nominal long-run growth of say also 3%. What do you think is going to happen to the value here?
well, the value with the long-term growth dropping should also drop.
Yeah, so algebraically, given that in this continuing value equation, I have R minus G in my denominator, well, 3% minus 3% is 0. Something divided by 0 is a problem. And so we've got an algebraic consideration here. Let me make it even worse still. Let's say that we've got, just an absolutely fantastic cost of funds. Such that it's 2%. Even if we apply a very common nominal 3% or even 2.5% long-run growth rate, we have a massively negative value building up here. But as an investor, wouldn't you love to have a nice, robust 20% growth rate for some period of years and then let that settle down to 3% and know that your cost of funds is even lesser still, 2%? Doesn't that sound like investment nirvana? Buddy, it does to me. And I've done a little bit of this. So we might write this off as simply an algebraic problem, right? But I think there's more than that. What's the rest of the problem? Can anybody see it or think about it?
Maybe I'll just stab one more time at this. Like if you have a growth that's greater than your cost of capital, you're talking about an impossible curve, right? Because you know that there's a marginal rate of return that happens for every dollar you spend, you'll get a certain rate back given to you, right? But we're saying that in perpetuity, for every dollar you spend, you're going to get $2 back or something like that. No matter how much you throw at that, that's impossible. There is a point in the curve in which your marginal rate of return is going to flatten out and then go down as you invest more money.
Yeah.
You can't have cost that continues to be below your amount of investing, like the cash that you invest.
That is a good way of looking at it. There's another one still. Isn't this cost of capital synonymous with some return? Haven't we argued that cost of a cost or a rate that's a cost is the other side of a coin of the rate that is a return? We've argued that, right? Well, how can I think of my R, my discount rate, my possible return here at 2%, and when the company's growing 3%? There's something wrong in this deal. If my return is only 2%, how is it I'm growing 3%? What's happening to the money in the middle? So this is an issue. And it's along the lines of what you were just trying to explain to us, Casey. So it's an issue. So there's something else as well. So let me take these numbers back to where they were. So I've got this really nice even number, negative $300 million. Did I have to go through all of this to find that negative $300 million, or could there have been an easier way? Think about this. Well, go ahead.
If I remember right, it was the 6 million, and you can just do it because if it's 20 in perpetuity, it's just the exact same as having the CV, the continuing value from there. Because there is no breakoff point.
That's exactly right. So another way of saying that is when the long run growth rate and the explicit period growth rate are the same number, there's no reason to go through a discounted cash flow for an explicit period and add to it the present value of a continuing value. Look at what I just did. I simply applied a Gordon growth model construction, taking the cash flow at time 1, which was $6 million, and I divided it by R minus G. And lo and behold, it gave me the exact same negative $300 million that I got to after spending all this time and headache. When the growth rate, when the long run growth rate is equal to the explicit period's growth rate, then there's no sense in doing a 2-stage or a double stage model. You may as well handle it just in a very simplified single stage model. So you noticed in my my final answer on this problem set that I indicated I wouldn't be a buyer of by-the-way boutiques. Not only do I not understand a high-end women's clothing boutiques, it's just not a business I understand, but I wouldn't feel as though the managers had any credibility when they put this 20-year projection in front of me. I think their credibility would be lessened even still when they put a double-digit growth rate into perpetuity. It just literally means they don't know what they don't know, and that's scary. Did that handle your question at all, Scott, and maybe 7 others you hope not to ask?
Yes, it did. Thank you.
Okay, you bet. What other questions might you guys have with respect to either this problem set or the rest of what you've been working on this week?
Can you show me how we did the NPV in the bottom part?
Down here?
That one, and then will you show me one more time where you duplicate on the bottom how you got the 11,309,591?
Yeah, and let me make sure I don't have an error there. No, I should be good. Okay, so recognize that as I'm coming through and replicating all these cash flows, Heather, from years 1 down to year 19, you got the exact same numbers as you've got up here. So this upper section and this lower section are giving you those same cash flows. But here I've added my cost function so I can have it in the same stack because IRR likes to pick up that stack. It's the only reason I've done that, by the way. And here I've recognized not only the cash flow in year 20, which we don't see here, but I've not only recognized the cash flow in year 20, but I've also recognized this benefit that I would receive as a function of all the future cash flows, and I've recognized it also for year 20, because if it's based on year 1 and it's as of year 0, remember it's value at time 0 is equal to the cash flow at time 1 divided by R minus G. That means that that number lives here in year 20 as a present value. So I'm going to take this present value cash flow, excuse me, this present value for year 20 as a cash flow, and this present value for year 20 as a benefit, and I'm simply adding them together.
Okay, I found my error on that one. Thank you.
Cool.
And then the next one was the NPV.
Sure. And I think in this case, yeah, I used a super simplistic NPV. I took the value of my, I took the present value of my benefits and subtracted from it the present value of my cost.
Does that always work for that one?
It always works. In fact, you'll notice, in fact, let me bring it up here real quick. I think that Jason and I were talking about this the other day. I want to bring up the model I have for one of your homework assignments. Okay. Notice here that I have 3 different versions of net present value. This one is the present value of the benefits minus present value of the costs. And you see I've just done it right from here. So I've got the present value of the benefits, all of them, and then I subtract from it the cost. Here I'm using the NPV function. Okay. And what the NPV function is doing is it's taking the sum of the present value of all the cash flows, the benefits and the costs. And they're all 3 the same number. So it literally, Heather, doesn't make any difference which one you use. If you're doing them correctly, you should always get the exact same value. Because here we've taken the present value of the benefits minus the present value of the costs. Well, here when we take the sum of all the present values, the benefits and the costs, that's the same thing as taking the present value of the benefits and subtracting the present value of the costs. And that's the function that Excel is doing for us. So all three of them are the same. Now, which one would I use? If I know the present value of my benefits, and if I know my cost, I'm defaulting to simplicity. I don't even have to calculate that. If I'm looking at my benefits at 18.81, I'm going to subtract 20, and I know I'm going to end up at 1.19. That's some pretty simple math. So it makes no difference as long as you're using them accurately.
Okay. Thank you.
You bet. What else might we like to look at?
Will you show me the MIRR one more time? I'm coming out a little bit.
The
Like just
MIRR?
Yeah, I'm coming
Sure.
out just a little bit different.
You want me to do it on this one, or you want me to do it on the one of the other spreadsheets?
On the investment one, so I can see
Okay.
what I'm doing wrong.
Yep, you bet. For the same, by the way, boutiques, or does it matter?
It doesn't matter. Just pick one of them. I'm doing it
Over
wrong
here,
on all
it
of
was a
them,
little bit
so.
easier. Okay. So it's the mirror function, and I'm picking up the same stack of cash flows that I would have used to pick up IRR, the exact same
Okay.
stack. And then it asked me to give it two rates, and those two rates is it wants a finance rate and a reinvestment rate. Let me show you. So I pick up the values, I got my stack, and now it wants two rates, a finance rate, which is going to be our discount rate, and then it wants a reinvestment rate, which in this case is also our discount rate.
Is it always the same rate, the same discount rate?
For our purposes, yes. If you were analyzing this in such a way that you had an alternative investment account for your surplus cash flows, and that you threw those surplus cash flows into that alternative account, and let's say that alternative account was a safe money account that was giving you 2.5%, then your reinvestment rate would be 2.5%, and your financing rate would have been 20 in this case.
Okay.
But for our purposes, we will keep them the same. Why is it that I believe I can do that? Why do I think I can plausibly, credibly keep them the same?
Yeah.
If I have calculated this discount rate of 20%, and if I've done it using a WACC construction, then it is a plausible, credible rate of the capital components that gives us a sense of their cost or risk and their potential reward, right? And so if I've assessed this as a purely market-based number of the existing capital components, then it would suggest to me that any surplus cash flows, I should be able to reinvest at that same plausible, similar rate. If I decided that I had a finance rate of 20%, like I have here for my discount rate, but a reinvestment rate of 40%, that's going to change my MIRR dramatically, right? But is 40% plausible in a market in which I believe I can get 20? Frankly, I think we'd argue that 20% isn't plausible as a consistently repeatable event. 5, 7, maybe 8. But Casey, you work with an investment firm. Would you guys ever forecast or depend upon having to receive a 20% return?
I would
No.
venture a guess that we don't.
In fact, it's the story you're going to sell your institutional investment clients. But when you're back in the room with your peers, you're going to say, no way, that defies credibility, right? Yeah. And that sets up, by the way, the difference between IRR and MIRR. Okay, so with that, let's move on.
I have a question.
Yes, Solomon.
I have a question for the quiz, and I was trying to understand, how do you find the, what do you call, the payout?
And when you say quiz, are you talking about the homework quiz or the practice homework? Solomon, are you talking about the practice homework or the homework?
Oh, the homework, the real one.
Okay, good. All right. So when you say payout, you mean the payback rates and such?
No, the payback, like at the bottom. you found out 5 and 7 discounted payback and payback. How do you?
Yeah. So how I did it was I actually have a fairly robust equation here so that I let Excel do it for me, but there's an easier way. Just look here on my payback. Now remember, payback is simply taking the cost of the investment and which as a negative and adding to it our positive cash flows. And it continues to do that until we get to a point where the net of those values becomes positive. Well, I noticed that that happens in the 5th year. Now I put together an equation so it does it for me, but I'm not sure that you necessarily want to play with that equation tonight. When you can just as easily eyeball this and say, oh, okay, I lay out 500,000, I get 75 back, I then get 86 back, I then get 99 back, I get 114 back, and in the 5th year I get another 131, and by then I have now gone positive in my overall cash flow experience. The discounted payback's a little bit different, but only a little bit. I take the same cost function, because that it's already a present value, and I take the present value of the cash flows, and I still do this just adding them up routine until I know that on a present value basis. It doesn't happen until year 7. So what's the difference? Well, here, if I'm just doing the regular payback, I'm not taking into account that money loses value over time. And here I am taking into account the money loses value over time. And it loses value at the rate of my discount rate. Why would we not say that it's at the end of year 4? Why would I say 5 instead of 4?
Because it goes
Because
into year 5.
It's still not done at the end of year 4.
Yeah.
You get.
Yeah, you're both right. It's still not done. I still don't have a positive return of cash. Forget present value or not. I just don't have a positive return of cash by that point, by the end of year 4. And it's sometime during year 5. Now, if I was doing a monthly projection, I would have been able to tell exactly what month in year 5 it would happen. But it's sometime during year 5.
Rick, so year 5 because it's positive?
Yeah, because I finally turned positive in year 5. So here in year 1, Jason, I spent $500,000. I get 75 back in cash flow, so I'm still at a negative 425. I'm going to add 86,250 to it. I'm going to add, but then at the end of year 5, I've added the next 131, which is for the entire year, right? So by the end of year 5, I have turned positive. Now, it probably happened sometime long about the end of November or the first week of December, if I'm using a calendar year, right? Because that 131,000 divided by 12 is a little over $10,000 a month of positive cash flow, assuming that they're similar each month. They may not be. This could be a seasonal business, right? And so sometime during year 5, my cash experience, my debits and credits netted out to a positive.
Because you included in the initial formula the cost.
Exactly.
Okay, because I was just summing it. And so, I mean, I arrived at the same answer, but at different years makes a lot more sense.
Yeah, you've got to include that cash, because we're trying to find out, when do we get paid back? When we get paid back the dollar amount. Now, I guess I could have done this without this number.
And you just see when it turns.
When it exceeds 500. Yeah, you could do the exact same thing. Yep. Good for you.
Thank you.
Thank you.
Certainly. Okay, with that, let's move on.